Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, there are more examples related to implementing the idea of trigonometric identities and the sum of two angles or the difference of two angles. And we are going to combine all those knowledge in order to solve all the examples that you're going to see in this video. Okay, let's start off with the first example here. Cos theta plus 90 degrees. So based on this, I can recognize that this is something like having cos A plus B. So this is finding the sum of two angles. So now based on that, this should be equal to cos A cos B minus sin A sin B. Okay, so therefore for this one we will have cos theta cos 90 degrees minus sin theta sin 90 degrees. So cos theta cos 90 degrees is 0. So we already know this because we have seen the special angles and what are the values for trigonometric function for special angles, like what is the value for cosine 90 degrees or sine 90 degrees and so on. So this you have seen already in the previous subtopic. Now minus sine theta, sine 90 degrees is equal to 1, and that can be simplified as negative sine theta. Okay, so that's the first question. Next we move on to the second question. So for this one, I hope you can see that we have sine something, cos something. So these two are different for x and x. And then we have minus cos something and sine something. So I hope that you are able to recognize that this is the same thing as having sine A cos B minus cos A sine B. And this is something that comes straight from sine A minus B. So this is the formula which you have seen in the early part of these trigonometric identities. So sine A minus B. Okay, when you have sine A minus B, then you will have sine A cos B minus cos A sine B. So therefore, for question B here, I can actually simplify, because the question is asking you to simplify the followings. So this can be simplified as sine 4x minus x, because my A here is 4x, my B over here is x, and because I have this expression which is similar to what you have seen over here, that can be simplified as sine A minus B. Now when we have 4x minus x, this is equal to just sine 3x. And that's the answer. The answer is sine 3x. Alright, okay, let's move on to the next example. So evaluate the followings without using a calculator. Okay, so again, whenever you see this long expression here, try to identify what's going on. Try to recall whatever trigonometric formula which you have seen before this. So we have cos 170 degrees, cos of something, times cos of something else, minus sine of something times with sine of something else. So this is clearly something that looks like cos A cos B minus sine A sine B. Now I'm sure you can clearly see that this is just cos A, and because this is a minus sign, that means cos A plus B. Okay, so this is the expression that we are looking for. So cos A cos B minus sin A sin B must be equal to cos A plus B. So we're going to start off with that one. Therefore cos 170 degrees cos 70 degrees minus sine 170 degrees sine 70 degrees will be equal to cos 170 degrees plus 70 degrees. Okay, we're just following this formula that we have over here. So now this becomes, you add up these two angles, so this becomes 240 degrees. And we're going to evaluate the answer, or find the answer to this one without using the calculator. So now we go back to having sketching the angle. So if you sketch the angle, 240 degrees, so basically it starts from here until 180 degrees and pass some more and maybe somewhere in between. So this is 240 degrees. And I hope you remember the idea of reference angle. So this is the reference angle. You can work with this angle. So if this one is 180 degrees, this must be 60 degrees in order to get 240 degrees, right? Okay, so this one is 180 and plus 60, you will get 240 degrees. So my reference angle is 60 degrees angle. And 60 degrees is a special angle which you have seen in subtopic 8.1. Special angles such that if I draw the triangle, maybe this is 60 degrees, this is 90 degrees, so this one is 30 degrees, and you have the length of it 1, 3 and 2. So this is what you have already seen in section 8.1. So once you are able to come up with this triangle and the length of the sides here, then you'll be able to answer what is cos 240 degrees. Now I hope you do remember the idea of on the first quadrant here, all trigonometric function here, cos, sine and tangent are all positive, and for the second quadrant only sine is positive. For the third one is only tangent is positive, and for the fourth one is only cosine is positive. Now since you are dealing with cosine and the angle is in the third quadrant, therefore the value here must be negative cos 60 degrees, because this is the angle that you're looking for. Now you are replacing cos 240 degrees with cos 60 degrees, and you have negative outside. Okay, you have to consider the negative sign because the cosine is not positive in this quadrant, only tangent is positive. And now cos 60 degrees can be found by looking at this right angle triangle. So cos of 60 degrees is 1 over 2, and so the answer is negative 1 over 2. Okay, so that's the answer for question A without using a calculator. Of course, you can check with the calculator and see that you got the same answer as shown here. Okay, so for question B, I'll just leave it to you guys to do it on your own. Question B, you have to follow the same idea which I just show you just now. So for this one, I'm sure you can see that this is clearly tangent A minus tangent B over 1 plus tangent A multiplied with tangent B, and this is just equal to tangent A minus B. And based on that, you can just continue in the same manner and should be able to get the answer to this question quite straightforward, pretty easy. Okay, right, so this is the last slide for subtopic 8.2. We are going to prove the following identities here. So maybe we can start with the first question, which is question A. So I'm going to consider the left hand side. Okay, so what I have here is I have this guy, so we have sine x plus y over cos x cos y. Now we can see that this is we need to use a formula for the sum of two angles, so this will become sine x cos y plus cos x sine y over cos x cos y. Now we can separate the terms, so it will become sine x cos y over cos x cos y plus cos x sine y over cos x cos y. And I'm sure you can see that we can cancel out some of the terms here. For example, cosine of y with cosine of y. Next, cosine of x with cosine of x. Then we are left with sine x over cos x. So this is the definition of tangent of x, plus sine y over cos of y. This is the definition of tangent of y. So there you go. You just managed to prove that the left hand side that you have here is equal to the right hand side. All right, now let's look at the last question, which is question B. Okay, so let's say we consider the left hand side of the equation. So we have here tangent theta plus cot theta. Okay, and you need to see that you get this 2 cosecant 2 theta. So what you need to do is maybe we can simplify the look by incorporating sine and cos, because we know that what is cosecant? Cosecant is 1 over sine 2 theta. So this one is cosecant 2 theta is 1 over sine 2 theta. And we know that sine 2 theta has something to do with sine theta plus theta. And from there we can go on and continue expanding it according to the formula which you have seen in the previous video. So now what is tangent theta? Tangent theta is sine theta cos theta. Cotangent theta is the reciprocal of this one, which is just cosine theta over sine theta. So next what I'm going to do is I'm going to consider finding the common denominator, which is going to be cos theta sine theta, and this one will be sine square theta plus cos square theta. And for this one you can use the identity, so the result for the numerator here will be equal to 1. So 1 over cos theta sine theta. So next what we can do is we can show you that cos theta sine theta is just sine 2 theta over 2. So this is equal to 1 over sine 2 theta over 2. Okay, now how do we get that one? So now you can see that from here sine theta plus theta is equal to sine theta cos theta plus cos theta sine theta, and this is just 2 sine theta cos theta, right? So this is just 2 sine theta cos theta. Now what I have over here is cos theta sine theta. If I know that 2 sine theta cos theta equals to sine 2 theta, okay, so now I'm going to write down this information here. Now I know that sine 2 theta is equal to 2 sine theta cos theta. Therefore, what is sine theta cos theta? What is this one? So this one must be, therefore sine theta cos theta must be sine 2 theta over 2. Sine 2 theta over 2. Do you agree? Okay, again. Now, I can see that cosecant 2 theta over here is 1 over sine 2 theta. Now, sine 2 theta is just sine theta plus theta. And if you expand this, you will get equal to 2 sine theta cos theta. Therefore, I can say that 2 sine theta cos theta must be equal to sine 2 theta. And therefore, I have this expression, this equation here. Sine 2 theta is equal to 2 sine theta cos theta. And because of that, I can find what is sine theta cos theta. So sine theta cos theta is just sine 2 theta over 2. So sine theta cos theta is just sine 2 theta over 2. And I get to replace that over here. Because here I have cos theta sine theta. Cos theta sine theta is the same as sine theta cos theta. And so I replace this term cos theta sine theta with sine 2 theta over 2, which is this one. Okay, so next what I have is I'm just going to continue the process. So this is equal to 1 times 2 over sine 2 theta, and this is equal to 1 over sine 2 theta. And I know that 1 over sine is cosecant of this angle. So this is equal to 2 cosecant 2 theta. Okay, so this is the angle is 2 theta. And there you go, you have managed to prove the left hand side is equal to the right hand side. Okay, thank you very much for watching.